On the floor of the Persian Gulf, resting in 60 feet of water, sits a steel cylinder the size of a compact refrigerator. It does not move, it does not broadcast, it produces no heat signature, no radar return, no acoustic emission of its own. It simply waits. Inside that cylinder, 3 sensors run on a continuous loop. A magnetometer, scanning for the distortion in Earth's magnetic field that a steel hull creates. A hydrophone, listening for the low-frequency rumble of propeller cavitation. A pressure transducer, measuring the displacement wave pushed through the water column by a passing ship. When all 3 signatures align, the mine classifies the target. Large vessel, valuable. The fuse fires. Iran paid between $15,000 and $60,000 for this weapon, depending on the variant. They have an estimated $5,000 to $6,000 of them. Now a ship enters the minefield. The magnetometer scans. No magnetic field. Nothing. The hydrophone listens. No propeller cavitation. Silence. The pressure transducer measures the passing wave. Nothing. The wave is below threshold. The mine sits there. It does not fire. It will never fire, because the ship it was engineered to destroy was deliberately engineered to not exist. That ship is the USS Avenger, and Iran's entire mine strategy has exactly one fatal flaw. It was designed to kill every ship in every navy on Earth, except this one. In October 1987, a Kuwaiti tanker named the Bridgerton struck an Iranian M-8 contact mine in the Persian Gulf. The mine cost approximately $1,500. The hull breach measured 6 feet wide by 15 feet long. The repair bill exceeded $5 million. The tanker was carrying 4,382 barrels of crude oil. That is the cheap end of Iran's inventory. The Sadaf 02, Iran's domestically manufactured influence mine, is the successor to that weapon. 3 sensors, programmable detonation threshold, and a design principle so simple that no engineer in 1942 would have found it surprising. The technology is not advanced. It does not need to be. One Sadaf 02 costs between $15,000 and $60,000, depending on sensor configuration. One Arleigh Burke-class destroyer costs $2, $1 billion. A cost exchange ratio of 1 to between 35,000 and 140,000, depending on which variant Iran chooses to put in the water. But the influence mine is not Iran's most dangerous weapon in the Strait. The EM-52 rocket-propelled rising mine, which we covered in a previous breakdown, launches a 308-pound warhead upward through the water column at 260 feet per second on a solid fuel rocket motor. You cannot outrun it. You cannot armor against a weapon that attacks from directly beneath the keel at rocket velocity. Iran's mine inventory operates across 3 kill mechanisms: contact detonation, influence detonation, and kinetic rising detonation. 3 different physics, 3 different counters required. A minefield containing all 3 variants in random sequence is not a battlefield obstacle. It is a probability equation, and the probability compounds every nautical mile a ship advances, except for one ship. Subscribe to Navy Decoded. We do not sail into minefields. We explain why one ship already did, and the mines never knew it was there. The United States Navy operates 11 mine countermeasure vessels of the Avenger class. The lead ship, USS Avenger, hull designation MCM-1, was commissioned on September 12, 1987. The same year the Bridgerton was mined. Every military analyst covering the Strait of Hormuz discusses carriers, carrier strike groups, F-35s, Tomahawk volleys, Aegis systems, VLS cell counts. Nobody discusses the Avenger class. In most news coverage of the current crisis, the MCM ships are not mentioned at all. There is a reason for that. The carriers and destroyers are the weapons that win wars. The Avenger class is the weapon that makes wars possible to fight. And the distinction between those 2 functions is exactly where Iran's mine strategy collapses entirely. But to understand why, we need to understand the weapon Iran built its strategy around, and then understand why the Avenger was designed from keel to mast to be invisible to it. Because this is not a story about a ship that sweeps mines. It is a story about a ship that influence mines cannot find. Iran's influence mine strategy is built on a kill chain with 3 links. Sever any one of them, and the mine does not fire. The first link is magnetic. Every steel-hulled warship generates a magnetic anomaly. The ship's hull concentrates the Earth's magnetic field lines the way an iron rod concentrates flux. A magnetometer on the seafloor can detect a destroyer-sized steel vessel from up to 50 feet in lateral distance. The signature is unique, persistent, and impossible to disguise on a conventional warship without extraordinary measures. This is why traditional mine countermeasure ships were built from wood. A wood hull generates no magnetic anomaly. The mine's magnetometer scans the water column and finds nothing to classify. The second link is acoustic. Propeller cavitation is the acoustic signature of a ship under power. As a propeller blade rotates, it creates low-pressure regions where water briefly vaporizes and then collapses. Each collapse generates a broadband acoustic pulse. Multiply that pulse across 4 blades rotating at 80 to 200 revolutions per minute, and the result is a distinctive low-frequency rumble that carries for miles in the water column. Iran's influence mines filter this signature by frequency. They are programmed to respond to the cavitation profile of large commercial vessels and warships, not fishing boats or small craft. The acoustic trigger is tuned to high-value targets. The third link is pressure. Any object moving through water displaces that water. A 250,000-ton supertanker at 12 knots pushes a pressure wave through the water column that an influence mine can detect from more than 150 feet directly below the hull. The wave is not sound. It is a physical compression of the fluid medium. The pressure sensor measures the magnitude of that displacement and compares it against a programmed threshold. Below threshold, no detonation. Above threshold, all 3 sensors in alignment, the mine fires. This 3-sensor architecture is Iran's great strength and Iran's great vulnerability. The strength, the 3-sensor requirement prevents accidental detonation by fishing craft or small patrol boats. Iran can lay influence mines in a shipping corridor, and they will wait for the right target, a tanker, a frigate, a carrier, without detonating on low-value contact. The vulnerability. If a vessel can suppress or eliminate all 3 signatures simultaneously, the mine's 3-sensor kill chain is broken at every link at once. The mine becomes a very expensive piece of metal sitting on the seafloor accomplishing nothing. No Navy on Earth has engineered that suppression across all 3 signatures simultaneously, except one. The USS Avenger, MCM-1, measures 224 feet from bow to stern and displaces 1,212 tons at full load. By naval standards, it is a small ship. Its crew of 84 sailors operates it at maximum speeds of 5 knots, with a standard sweep speed of 5 to 8 knots inside a minefield. On paper, nothing about those numbers is remarkable. What is remarkable is everything below the waterline. The Avenger's hull is constructed from 4-inch thick Douglas fir and Alaskan yellow cedar planking, laminated and fiberglass sheathed on the exterior. It is the first U.S. Navy vessel built with a wooden hull in more than 50 years when it was commissioned. The superstructure is glass-reinforced plastic. The decking is non-ferrous throughout. The fittings, the hardware, the fixtures, bronze, stainless steel, aluminum, fiberglass. The ship was designed around one principle: present no magnetic signature to any mine on the seafloor. But the wood hull is only the beginning. Throughout the ship, a system of degaussing coils, copper windings embedded in the hull structure and powered by the ship's electrical system, generates a counterfield that cancels whatever residual magnetic signature the ship's equipment would otherwise produce. The coils are calibrated periodically in specialized degaussing facilities, where engineers measure the ship's magnetic profile with precision magnetometers and adjust the coil current until the anomaly is reduced to effectively 0. The mine's magnetometer scans. It finds nothing. Link 1 of the kill chain, severed. Now the acoustic link. The Avenger's 2 main diesel engines, Isata Frashini ID-36 SS6V diesels, each producing 600 horsepower, are mounted on Prairie Masker vibration isolation systems. Each engine rests on a series of engineered isolator mounts that prevent the engine's rotational vibration from transmitting into the hull structure and from there into the water column. The ship's twin controllable pitch propellers are specifically designed to rotate at low RPM and high pitch angle, reducing cavitation at operational sweep speeds. At 5 to 7 knots inside a minefield, the propellers produce a cavitation signature orders of magnitude below the acoustic threshold of any influence mine programmed to target full-size warships. The mine's hydrophone listens. It hears nothing classifiable. Link 2 of the kill chain, severed. Now the pressure link. A 1,312-ton vessel moving at 6 knots through water generates a pressure wave. The physics cannot be entirely eliminated, but the pressure signature of the Avenger at sweep speed is dramatically below the detection threshold of mines calibrated for tankers and major combatants. A supertanker at 12 knots displaces water with a force measurable at 150 feet depth. The Avenger at 6 knots displaces water measurably at roughly 20 to 30 feet depth. The mine's pressure sensor is set to a threshold it will never reach. Link 3 of the kill chain, severed. All 3 links broken, simultaneously, by design. Iran spent billions of dollars and decades of engineering developing a mine inventory built around 3 sensor triggers. And the United States Navy built a 224-foot wooden ship that trips none of them. But the Avenger is not just a ship the mines cannot see. It is also a ship specifically equipped to find and destroy those mines before any other vessel enters the corridor. The AN/SQQ-32V3 mine-hunting sonar, built by Raytheon, is the Avenger's primary detection system. Mounted in a retractable gondola beneath the hull, the SQQ-32 operates in 3 modes. Active sonar transmits a pulse and processes the return to build a 3-dimensional acoustic map of the seafloor within a 200-meter corridor. Classification algorithms distinguish mine-shaped objects from rocks, coral, and debris by shape, analysis, and acoustic reflectivity profiling. The system has been upgraded continuously since the original Avenger commissioning, and now processes returns in near real time. For mines buried in silt or partially obscured, the AN/AQS 24A towed mine hunting sonar, a torpedo-shaped body towed on a cable at depths down to 100 feet, provides side-scan sonar imagery of the seafloor at a resolution sufficient to classify objects as small as 6 inches in diameter. Once a mine is located and classified, the Avenger has 3 kill options. The Mark IV Mod 0 wire-guided mine disposal vehicle, a 75-inch diameter remotely operated torpedo body, carries a shaped charge to the mine, positions it against the casing on fiber optic video guidance, and detonates. 1 mine destroyed. The vehicle is expendable. Cost per disposal, approximately $28,000. Against influence mines specifically, the ANSSLQ-38 acoustic and magnetic minesweeping system, a towed cable assembly generating a programmed magnetic field, and an acoustic projector broadcasting a simulated ship signature, can be deployed to lure influence mines into detonating against a target that does not exist. The mine fires its warhead into empty water. The mine is gone. The Avenger sails on. For cleared corridors, the Avenger drops data marker buoys at precise GPS coordinates, building a verified safe lane chart that subsequent traffic can follow. Every ship that transits behind the Avenger does so on a chart signed by its sonar operators. This is not a minesweeper in the World War II sense, a vessel dragging wire cables hoping to snag mine tethers. The Avenger class is a precision mine hunting system with a non-magnetic hull as its first line of defense and 3 independent detection and neutralization systems as its operational toolkit. At this point, most coverage of mine countermeasure operations would show you footage of the Avenger class and call it a sophisticated mine hunting system. Impressive capability. Moving on. But this is Navy decoded, and the real question is not what the Avenger can do. The real question is why Iran's entire mine strategy, 5,000 to 6,000 mines, decades of procurement, the largest mine inventory in the Middle East, collapses against this one class of vessel in a way that no other threat in the Iranian arsenal collapses against any single American platform. The answer involves 3 systemic failures in Iran's mine doctrine that most analysts have never examined together. And understanding those 3 failures explains not just how the Avenger defeats the mine threat, but why Iran cannot fix the problem even if it sees it coming. Failure 1. Iran built a weapon that defeats itself. Iran's influence mine doctrine requires target discrimination. The 3-sensor kill chain exists specifically to prevent accidental detonation on low-value targets. Iran does not want its mines triggering on fishing boats, dhows, or small patrol craft. It wants them to wait for tankers, frigates, and carriers. That target discrimination is precisely what the Avenger exploits. By presenting no magnetic anomaly, no classifiable acoustic signature, and no pressure wave above threshold, the Avenger does not register as a valid target. To the mine's logic circuit, the Avenger is a small, slow, non-ferrous vessel, acoustically and magnetically indistinguishable from background noise. The mine waits for a real ship. The Avenger clears the corridor. The real ships follow behind on a verified safe chart. Iran built sophisticated target discrimination into its mines to make them more effective against the U.S. Navy. That sophistication is exactly what makes them blind to the U.S. Navy's countermeasure vessels. The mine that was smart enough to wait for the right target cannot recognize the one ship designed to clear it. Failure 2. Iran has no counter to a ship it cannot threaten with the weapon it laid. Iran's fast attack craft swarm doctrine, which we covered in our A-10 breakdown, is designed to drain VLS cells and overwhelm Aegis radars with simultaneous multi-axis threats. The IRGC Navy operates more than 1,500 fast attack craft specifically for this engagement, but fast attack craft cannot operate in their own minefield. Iran cannot send speedboats to chase down the Avenger in a corridor seeded with influence mines. The speedboats have steel hulls. They generate magnetic signatures. The mines in the corridor do not recognize IRGC registration numbers. They fire on whatever crosses the threshold, including Iranian craft. The Avenger operates in a space that Iran has made inaccessible to its own surface fleet. Iran's naval advantage, numbers, speed, swarming tactics, is neutralized in the exact geography where the Avenger works. And the Avenger works precisely in the geography Iran mined most heavily. Iran's mine strategy closed the strait to Iran's own conventional countermeasures against the one vessel that needs to be stopped. Failure 3. Iran built a one-time weapon against a reusable process. Iran's mines fire once. One mine, one detonation, one expenditure of $15,000 to $60,000 of weapons inventory. After detonation, that mine is gone. The Avenger's detection and neutralization systems are reusable. The AN/SQQ-32 sonar generates the same data on the 500th sweep as on the first. The Mark IV disposal vehicles are expendable but cheap, $28,000 each, roughly half the cost of the cheapest mine they destroy. The AN Hourage SLQ-38 sweeping system is towed and retrieved repeatedly, luring mines into self-detonation at a cost of fuel and operating hours. The math here is the inverse of every other weapons exchange at Hormuz. Every other Iranian threat, Noor anti-ship missiles, Qaher-fast attack craft, Shahab-3 ballistic missiles, can be replaced. Iran manufactures them domestically. The drone factories, as we reported in a previous breakdown, were struck in Operation Epic Fury. But before those strikes, Iran's production capacity was continuous. Mines are different. Once a mine fires, it is gone. Once a mine is located and neutralized by the Avenger's disposal vehicles, it is gone. And Iran's mine production facilities, the sites on Karg Island and the manufacturing complexes inland, are now ash. The mines on the seafloor of the strait are the last mines Iran will ever have. The Avenger does not need to be fast. It does not need to be heavily armed. It needs to be patient, systematic, and indestructible by the weapon it is hunting. It is all three. As of now, USS Pioneer, MCM-9, and USS Chief, MCM-14, are the two Avenger-class vessels currently forward deployed to the 5th Fleet Area of Operations out of Naval Support Activity Bahrain. Both ships have been conducting mine countermeasure operations, in coordination with coalition partners since the strait closure began. They do not appear on the front page of any newspaper. They have not been named in any White House briefing. The carrier strike groups get the headlines. The Avenger class gets the work. When the three conditions we have covered in previous breakdowns converge, the mine production faucet shut, the Tripoli carrier group protective bubble in position, and Iran's economic hemorrhage reaching maximum leverage, the Avenger class will begin systematic corridor clearance operations inside the strait. 2 ships, 11 total in the class, each capable of clearing a verified lane 200 meters wide at speeds of 5 to 7 knots, charting safe passage for the 150 tankers currently anchored outside the strait, carrying combined cargo worth approximately $12 billion. They will do it without presenting a magnetic field to a single mine, without generating a cavitation signature any acoustic sensor can classify, without pushing a pressure wave above any trigger threshold. The mines Iran spent decades acquiring and billions of dollars stockpiling will sit on the seafloor scanning for a ship that has already passed overhead and is already 2 nautical miles ahead, laying the next datum marker buoy on a GPS grid, marking the corridor clear. The equation that Iran designed for maximum asymmetry runs in exactly the wrong direction when the Avenger class is in the water. A $60,000 mine, a $277 million ship that the mine cannot see, a cost exchange ratio of 1 to $4,600, but this time in America's favor. On the floor of the Persian Gulf, the influence mine still sits, the magnetometer still scans, the hydrophone still listens, the pressure transducer still measures. A ship passes overhead. 224 feet long, 1,312 tons. Moving at 6 knots through 60 feet of water on a non-ferrous hull over Dagost copper coils, its diesels sitting on vibration isolators, its propellers turning at 40 RPM in high-pitch configuration, producing a pressure wave. The mine's sensors register as background sea state, the magnetometer scans, no anomaly, the hydrophone listens, no cavitation, the pressure transducer measures, below threshold. The mine does not fire. 70 meters behind the ship, a Mark IV disposal vehicle drops from its launcher on a fiber optic tether and descends toward a target coordinate the SQQ-32 mapped 2 minutes ago. The operator in the Combat Information Center watches the video feed. The mine comes into frame. The operator presses a button. The shaped charge detonates. The mine's casing fails. The warhead is destroyed in place. 1 mine gone. Iran's mine production facilities are ash. There are no replacements. The Avenger advances 200 meters and the process begins again. Every other vessel in every other navy on Earth enters a minefield and confronts an equation weighted against it. More mines than sweepers. Cheaper weapon than the hull it destroys. The oldest weapon in maritime warfare against the most expensive assets afloat. The Avenger class enters a minefield and changes the variable that breaks the equation. Not by being faster, not by being more heavily armed, not by being cheaper, though at $277 million, it costs less than 1/8 of the destroyer it is protecting. By being invisible. Iran spent 40 years and billions of dollars building a weapon that cannot see the one ship designed to destroy it, and the ship was built in 1987 from wood. Naval mines are the cheapest, most patient, most psychologically effective weapon in maritime warfare, but every mine is blind to something. The Avenger was designed to be that something, and every mine it clears is one Iran will never replace.